Hey again, guys and girls. Well, I guess statistically, pretty much guys. I've got some packages here. Only 4 this time, but I think one of them is a double. And you might hear the laundry going on the background. Nothing I can do about that. My workspace is in the basement. Let's get to it. First one up is this super descriptive one that says electronics times 1. This is our double package, so it took a month and a day. And one's $1.44, the other one's $1.82. Okay, one of these guys, and one of these guys. Let's take a closer look at those. I got you guys a little zoomed in for this first one here. What this thing is supposed to be a SMD manual vacuum pickup tool. So basically it's just a little bulb that you squeeze, and there's a little sort of a tip to it. And if you squeeze and you block the tip, it holds a vacuum, and you're supposed to be able to pick up little components. So we've got this straight tip here with a big suction cup. Got this angled tip with a tiny suction cup, and this other angled tip. Although this one looks like it just got, they both look kind of kinked over. I don't know how high quality this is. But yeah, seems interesting. Pile of Stuff got one of these, and I figured I would give one a shot too, because I do like the concept of SMD soldering. I'm not very good at it, but I do like it. And sometimes, like the little tiny tweezers that you use to pick up parts, like these guys, they can get magnetic, or they can just hang on, or even like it's hard to get at the right angle. If you grab something from the top of the little vacuum thing, I think that would be ideal. So I'm going to zoom you guys in, and we're going to try to pick up some tiny components with this kit. So I'm going to start with this straight tip with the giant. Actually, you know what? I'm going to get an angled tip just because it probably looks better for filming. So I'm going to grab this super angled tip, which is, it's just kinked over. It's very interesting how they've done that. But I'll put the big suction cup on it. There we go. Should still work. I'm going to put this tip on this other guy so I don't lose it. And the first challenger is this, let's see, don't know how to count, 14 pin chip. I think it's a 74HC14D, whatever that is. I've long since forgot what it was since I've ordered it, but I'm going to give it a try. So I'm just going to squeeze, put it down, and let go. Not really working. Nope. Nope, that's not really working. Let's try a smaller tip. It feels like I can't get a good seal because the cup is bigger than the actual chippy here. Okay, let's try this medium-sized one. No, it doesn't seem to hold. No, no luck. Can't get a good seal. Let's try with one of these tiny tips. It's definitely creating a vacuum, because it does hold the vacuum reasonably well on my finger. Let's try it on this with this tiny tip. Yeah, you get a couple seconds. I don't know if really this is the way to go. I think really the way to do this would be to have a vacuum pump pulling a vacuum. Yeah, it lasts for a couple seconds. Yeah, it lasts, a few seconds. Let's try something smaller. So I got this guy. This is the NE555P. Let's see if that's any better. Yeah, that one actually holds for quite a while. I can actually work with that. It does lose vacuum pretty quickly, but maybe a little bit of silicone lubricant. Oh, there, this one's holding now. Maybe a little bit of silicone lubricant at the tip here. Just a whiff of it maybe would help. But there we go. That's good. And the last challenger, this little guy. This is a small MOSFET, I believe. I feel like there's no way this thing's going to work, but give it a shot anyways. Probably in the shadow there. Look at that. It works. And then to release, no, that was only stuck in the soft rubber actually. The vacuum had nothing to do with it. There we go. To release. Yeah, nope, that was stuck in the soft rubber. Yeah, I'm not sure about this. This was $1.81 Canadian. I don't know. I'll play with this some more, but for now I'll say if you're looking at one of these, this one's not the one. I'm actually going to talk to Pile of Stuff about how he felt about his to see if I can recommend any to you guys. Maybe I'll try ordering a different one, but yeah, this one ain't it. The next item that was in that envelope is this guy. This was $1.44, and viewers on the channel should already recognize this thing. But if you're new around here, this is a PIR module. So it's a PIR sensor on top of its own circuitry. So this is all self-contained. Basically, you're going to have a positive, negative, and an out in the middle. This particular module goes from somewhere around 4.5 volts up to 20 volts, and the output, the high output in the middle, is 3.3 volts, and it is high when it senses a difference, a movement of infrared energy around a pretty much like 120 degree cone. So I bought this one because I used the last one in a let's go here, in a skeleton for Halloween. And so because it's installed, I need to replenish the stocks. This is the best way to do it. So here it is. So I'm going to give this a shot. Got my module here at 5 volts. And the positive seems to be at the lower end here. So that's positive there. Actually, I'll move that up a bit, give me some space. Positive here, negative here. And for output, I need an LED. I thought I had one kicking around here. I do. Like this. And I put the middle into here. And this should work just fine. It may have little problems because of the voltage fluctuation, but we will see. So I'm going to give that a minute. Right now, it's drawing no current. Not 100% sure. Oh, there we go. LED is lit. So now I got to give this a minute to sit there, and it has to stabilize, and then we can move around and see if it captures us. Trying my very best not to move now. So the LED is off, and as soon as I moved. So basically the LED is off, and as soon as you move kind of on top of this cone here, the LED will turn back on, and I think the default is around 8 seconds delay, and then it should turn back off. But I found that if I'm anywhere near this module, it's very sensitive, and it'll probably pick up movement a lot better than you think. So maybe I can bend that up. Can you tell that LED is on? Yeah, you can. So I'm going to face it away from me. And just tilt that up quite a ways. Okay, you could still tell the LED is on, but now I should be outside of the influence. There we go. LED is off now, and even though it's only been a couple minutes, I should be able to trigger it. Yeah, there it goes. So LED is on now. So this thing is working. It's functioning properly, which is great. So I've got another one to put in my stock of parts, which means that I have another opportunity to make another cool device out of it. Next one here is marked 1 times light bulb. It took under a month to get here, and it was $1.18 at auction. As you can imagine, it is a light bulb. Oh boy, is it ever a light bulb though. So this is not a standard socket. I thought this was a standard socket, but it's more like I don't really know what it's called, but it's the little ones, like the little candle sockets. I think this is aluminum, and you can see right into the dome here. This chrome sleeve rotates, and if I hold the chrome sleeve, so does this plastic. I'm not 100% sure if I want to plug this in. Oh, so I just pulled that off. It looks like they tried to cut threads on the end of these fins here, and what's inside seems to be 3 of these either 1 or 3 watt LEDs, and there's a screw missing. There's only 2 screws. Huh. Very interesting. I think I'll go a little bit further. I think I won't plug it in to determine if it's working or not, but I feel as though I should at least maybe see what it's all about. I don't know. If that's a capacitive dropper, then these wires are just live. They're live at 115 volts. Ooh, these screws are chewy. These are so these holes are not threaded. These are self-tappers. This is an extremely cheap light bulb. Oh, this one I believe is cross-threaded. Oh yeah. A little bit of thermal compound there. And this is capped. Oh, this end is threaded as well. Oh boy. That's a little cheap driver. Well, if you want to see me experiment with this light bulb, let me know in the comments below, and that can be arranged, because I don't think I'm going to be using it as is. It's a little bit of danger associated with it, which is okay to have a little bit, I guess. Gotta live sort of precariously one day or another. But yeah, if you want to see me risk life and limb tearing this down and plugging it in, I will do that for you. But you gotta let me know in the comments, because gotta get that audience retention and audience sort of engagement numbers. That's what I was looking for. Wow, that hole's already cross-threaded, or stripped, I should say. And then this should thread. It looks like they cut threads, but oh, my ears. Jeez, yeah, it's kind of like, whoa, very low quality bulb, but hey, if we can have some fun with it, all the power to us, I guess. Let's go on to the next one. Next one up is this guy here, $1.72. exactly a month to get here. And the description is sensor. Sensor indeed. It's another PIR sensor. So let's take a closer look at this one. So I just brought in the sensor we just looked at for scale. Uh, this guy is absolutely tiny. Just ridiculously small. But it should work exactly the same as this guy. I just believe that they have built more functionality into the actual PIR. Although I'm not sure. Maybe that's not actually true. I feel like possibly this is an op amp. I'm not sure because it doesn't have any numbers on it. But maybe this one here is just driving a MOSFET directly. Hard to say. I'm going to take a closer look at this on another video, but for now let's see if we can kind of power this up the same as this one. And I'm just seeing here, it's not marked. The polarity is not marked. So I just have to guess and hope I don't blow it up. It should be good up to 12 volts. I'm going to assume they're pin-to-pin compatible. That's quite the assumption to make, I understand. But I don't really have another choice right now. So one there and one there. Okay, let's see if this LED lights up sort of when I turn it on. 5 volts, same as before. This one maximum 12 volts. Oh, it's on constant current. That's not good. Oh, I had the wires touching. That's probably why. Let's put that there. Put this up here. Alright, let's give this a shot. Constant current again. I feel like the polarity is not the same. Let me do a little bit of research and I'll bring you back. So the polarity on this guy, it's actually reversed. If looking from the top here, I don't know if you're able to see it, but the transistors on kind of this side, that's the positive side, and on this side is the negative side, output still in the middle. However, the output is so weak on this thing that it will not drive this LED. This LED, I think I set it up to pull about 18 milliamps, and it can't drive that much. Even so, the voltage is a bit low. As you can see, I just crossed in front of the threshold. 2.92 volts we're getting out of this thing instead of the 3.3 on the other one. And look how quick it recovers. So there's the 2.92, and then it's going to go on for a few seconds and then turn off. And then it's only blocked out for a few seconds, and then you can turn it right back on. So I wanted this for a more compact application. But in fact, it looks like it'll be for a different application altogether. Something where I need to use an output transistor or MOSFET, and something that will be okay with the kind of 3 volts out, so a logic level MOSFET at that. So yeah, I don't know. I'm going to experiment with this thing and we'll see what we can come up, but this is very interesting, and I'm glad I grabbed this one because in the future when I'm doing projects for you guys, I can recommend not to get this one or to get this one depending on if the project allows for it. I kind of figured they were all very similar, but I guess not. And the last package up for today, unfortunately there's kind of a spoiler on this one. Look at that. Dashboard dash panel gauge bulb times 1. So we should have a single gauge cluster bulb in here. $1.14, November 11th to December 12th, just over a month. And so I'm just going to open this like that. And we have 10 bulbs. Now, I knew I was going to get 10 bulbs, of course. These things cost maybe like $2 or $3 each, locally, and from eBay, $1.14 Canadian, that's about 80 cents or so American for 10 of them. Now, these are automotive bulbs, 12 volts. They are T10 style. So if you want to get the exact same thing, you're looking for T10. And the reason I got these things is because I'm interested in making some very basics oriented videos, teach circuit basics to people just learning. And if you use an LED bulb, it's not the same. You can't really measure the resistance on an LED bulb in the same way that you can in just a filament bulb like this. And visually, it's not quite the same. So I figured this would be nice, a nice change to change it up, get a nice old school style bulb, but I also didn't want it too bright where it would be too flashy and swamp the camera and you won't be able to see any of the meters. So this being a 12 volt light, I'm going to set it to 12 volts and we'll see how bright it is. Hopefully it's not too bright. I was hoping it would only be moderately bright. Well, I'm constant current here. So how much current are we drawing? Quarter of an amp. Set this up to 1 amp limit. There we go. So we're drawing 300 milliamps, which is quite nice. And this gives off a moderate glow, so you guys can see it on the camera. I'm not blinded by it. It's a little bright, but it's not too bad. And I can have gauges and stuff around here to show us these things. Now I'm going into constant current from time to time. I don't know what's happening here. I shouldn't be going into constant current. It's almost as if maybe I'm getting inductive spiking because this is a filament bulb on a switching power supply. That is possible. Or my connection's just no good. But yeah, I have some accessories from this coming. I have some bulb sockets. So expect that on a different mailbag. But yeah, I figured something from the automotive world to help teach electronics on YouTube. So yeah, 10 of these, $1.14, really good value, like a tenth of the price or less than what they are locally. And so yeah, figured I'd pick some up. And so this pile of awesome goodness, lights and sensors, I guess, is today's mailbag. I want to thank you all for watching. And I want to thank my Patreons, most of all because they're the ones who give me their support and make me feel as though what I'm doing is reaching you guys, which is great. If you guys want to join, check the Patreon link in the description below. And same thing to my watchers. I love when you guys come by. I love when you watch the videos. I love when you comment. So keep on doing that. And if you want to see more, make sure you're subscribed. Thanks again for watching.